Why is Earth so restless? What causes the ground to shake, volcanoes to erupt, and great mountain ranges to rise to incredible heights? The face of Earth is continually shifting, influenced by a process called plate tectonics. Earth's surface, the lithosphere, is a mosaic of many plates girdling the planet like seams on a baseball. These plates drift on top of Earth's hot and slowly churning mantle, over time colliding, breaking apart, and grinding against each other. To understand tectonics, scientists look back only 200 million years, because earlier geologic evidence has been either recycled or hidden by Earth's processes.
To appreciate the idea of continents moving, you have to step outside human timescales and think in terms of a completely different time frame. The continents here are drifting apart at 2 centimetres every year. In my lifetime, we're talking just a couple of steps. Even in 1,000 years, that's just 20 metres. It's only when you start to think in terms of millions of years that you realise just what can happen. $225 million years ago, our planet looked very different. All the continents were joined together in a single supercontinent called Pangaea. As the plates moved, this supercontinent broke up. New oceans formed as continents drifted around the globe. It's this that has created the shape of the world we know today. But the plates never stop moving. In the distant future, our continents will once again be reunited in a new giant supercontinent.
Now there was a geological mechanism to explain continental drift.
That's simple.
Once you hear it, it sounds great.
It does sound great.
By the 1960s, both ideas were synthesized into a single theory, the science of plate tectonics. A great discovery that revealed just how complex and dynamic our planet is. Several groups of scientists had concluded that not only is the Earth's crust moving, but the surface of the planet is broken into large, interconnected plates. These plates are constantly in motion, floating on a layer of molten rock in the Earth's mantle.
It happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in 2 directions and goes sideways. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart. And it's this that ultimately causes the continents to move.
Among the most dramatic and visible creations of tectonic forces are the lofty Himalayas, which stretch 1,800 miles along the border between India and Tibet. About 50 million years ago, India separated from Madagascar and began a record-breaking race to the north. Normal movement for a plate would be about 1 foot every decade. But the Indian plate was on a fast track, moving more than 29 feet in a century. The massive collision between India and Eurasia thrust up Earth's crust, forming the jagged Himalaya mountain range, and raised the roof of the world. India pushed as much as 1,800 miles into Eurasia and continues to shove north nearly 2 inches a year.